Hello students, welcome once again to Saurav Sir's classes. So in the previous video on real analysis, okay, we had done what? We had done squeeze theorem, squeeze principle or theorem, then Cauchy's first principle, okay, then Cauchy's second principle, okay. So these are the things we had done in the last class, okay, in the last video I mean. Today we are going to continue or we're going to just write Cauchy's second principle. Second principle on limits, okay. Cauchy's second principle on limits. So what was Cauchy's second principle on limits? It will be n tends to infinity, a n whole to the power 1 by n is equal to limit n tends to infinity a n plus 1 by a n. This was Cauchy's second principle on limits. Now I am going to start with an example on this second principle on limits. Okay, it's a question, so check it out how I am doing. So it says proof limit n tends to infinity 2 by 1 to the power 1, 3 by 2 to the power 2, 4 by 3 to the power 3, then n plus 1 divided by n to the power n, okay, whole thing to the power 1 by n. You have to prove that it is equal to e. So let's start. So let a n is equal to 2 by 1 to the power 1, 3 by 2 to the power 2, 4 by 3 to the power 3. Okay, so let's go ahead and we're getting n plus 1 divided by n to the power n. Next one, a n plus 1. So what will a n plus 1 be? Same thing. From here we have to continue like you have done in mathematical induction. Okay, so 4 by 3 to the power 3, continue. This will be n plus 1 divided by n whole to the power n, and this will be n plus 1 divided by n plus 1 whole to the power n plus 1, right? So let's write a n properly. So I mean a n plus 1 properly. So a n plus 1, 2 by 1 1, 3 by 2 2, n plus 1 to the power n, okay. Now what we need to do is just hold on, let me use a little color here. Yeah, this a n, okay, what we need to do is this a n will be now the denominator, a n plus 1 will be the numerator, okay. So let's write it. So a n plus 1 divided by a n. So what is a n plus 1? A n plus 1 is this whole thing, okay. So just let's write it. that will be 2 by 1 to the power 1, 3 by 2 to the power 2, dot 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 n plus 1 divided by n whole to the power n, and n plus 2 divided by n plus 1 whole to the power n plus 1. Okay, just one sec. One second. Okay, let's write it. I know you cannot see I have written it uselessly so much, with so much of gap. Just give me 1 sec. I'll write this 1 second. Okay. This is what you need to see. Okay, it's not written properly. Let me just scroll down a little bit so that I can get much more better space. So a n plus 1 divided by a n is equal to 2 by 1 to the power 1, then 3 by 2 to the power 2, dot dot dot, that is, what was it, n plus 1 whole to the power n. Okay, then n plus 2 divided by n plus 1, most probably, yes, n plus 1, and down here it's 2 by 1 to the power 1, 3 by 2 to the power 2, dot dot dot, n plus 1 divided by n to the power n. So from here this got cancelled out, right? So we have a n plus 1 divided by a n is equal to n plus 2 divided by n plus 1 whole to the power n plus 1. Okay, now from here we need to write limit n tends to infinity a n plus 1 by a n is equal to limit n tends to infinity n plus 2 by n plus 1 whole to the power n plus 1. So this can be written as limit n tends to infinity n plus 1 divided by n plus 1 whole to the power n plus 1. Let's scroll down. So this finally becomes limit n tends to infinity 1 plus 1 by n plus 1 whole to the power n plus 1. So which is equal to e. Alright. So limit n tends to infinity, okay, a n plus 1 by a n is equal to limit n tends to infinity 1 by 1 plus 1 by n plus 1 whole to the power n plus 1 is equal to e. Proved. Okay, now all of you all know how this is e. Okay, how this part is e, all of you all already know. Okay, so in case those of you who don't know how this part is e, so let me just show you. Let say f of n say is equal to 1 plus 1 by n plus 1 whole to the power n plus 1. Okay, now you do this taking log on both sides. Okay, taking log on both sides. So take log. So this is log f of n is equal to log 1 plus 1 by n plus 1 whole thing to the power n plus 1. So what happens? The n plus 1 comes in front. Yeah, we have log bracket 1 plus 1 by n plus 1. Now from here what happens? You can bring the n plus 1 down, log 1 plus 1 by n plus 1 whole thing divided by 1 by n plus 1. Okay, so why did I do 1 by n plus 1? I'll show you. Okay, now when you take limit n tends to infinity on both parts, so if you do like this, limit n tends to infinity log f of n is equal to limit n tends to infinity, the top one is log 1 plus 1 by n plus 1 divided by 1 by n plus 1. So you notice this, that the top part, okay, the top part and down part both are coming 0 by 0, right? 0 by 0. So that is an indeterminate form, correct? So what do we do in the indeterminate form? This is what we do in the indeterminate form. Okay, we have to use L hospital rule, applying L hospital rule. Okay, you know it, applying L hospital rule. So let's find the derivative for the numerator as well the denominator. So what do? We do ddn, okay, of log 1 plus 1 by n plus 1 whole thing divided by ddn of 1 by n plus 1. Alright, so from here what do we get? So that was ddn of log n 1 plus 1 by n. So log means 1 by bracket 1 plus 1 by n plus 1, okay, into chain rule says 0 plus minus divided by n plus 1 whole square. Okay, whole thing divided by, don't write the equal to sign there, equal to minus 1 by n plus 1 whole square. So check it out, this and this got cancelled out. You're left with just, if you do, you're left with n plus 1 here, n plus 1 here. So it's coming as 1 by 1 plus by n plus 1. You can keep it like that. Okay, now let's go and use the limit for on top. Okay, so this will be limit n tends to infinity log f of n is equal to limit n tends to infinity 1 by 1 plus 1 by n plus 1. So this part is 0 when you put infinity, elsewhere you cannot put anywhere infinity, so this is 1. Okay, so limit, now you can write log outside, log limit n tends to infinity f of n. Okay, so this means what? Log e, right? So this is log limit n tends to infinity f of n is equal to log e. So limit n tends to infinity f of n is equal to e. So that is what it is. That is what we are trying to prove, right? And you can just write e like this from here. There is no problem. You can write e like this, because I had given you a formula. When the powers, when the base, when the denominator and that power is same, For this, when limit n tends to infinity, then it will become e. Alright, so by now you have already understood how you are going to get the answer in short form, although you don't have to use this long one, but if you want to use, you can use the long one also, but I suggest to use the short form and find the answer. Okay, so this was one example on the second theorem of Cauchy. Because these theorems are big, so you'll get beautiful sums on these, beautiful questions. So anyways, we have learned only the second principle for this video, and we have finished the second principle with an example by proving that the limit of this whole thing is equal to e. Okay, so keep taking as much help as possible, because all the help that you need always will be provided at Saurav Sir's classes. Thank you for watching.